Hello guys, it's Sayyid Muhammad Wakas. I'm here back with another video. In this video I will tell you guys how you can calculate this diffuser size, and you can select diffuser from the supply data sheets. So let's start. Let's take an example of this FCU 3FC L1. As you can see that we have got 3 diffusers over here, 3 supply and 3 return, 3 supply and then 3 return, 2, and this is a third return. So I will tell you how you have got 9 by 9 inches for that diffuser. As you can see, the machine CFM is about 199 multiplied by 3, it's 597 CFM. So if you want to check the size of the diffuser for 199 CFM, because machine CFM is 597 and 597 divided by 3 we got 199. So we have got 3 supply return diffusers, 9 by 9 inches, 199 CFM each. So this is the formula we are going to use to calculate this diffuser or air terminal size. What the CFM we got over here is 199. So CFM divided by 400 multiplied by 144, and if you will take the square root of this one, you will get the diffuser size in inches. So how much we got over here is 8.46 inches. And if you know the standard size for the industry, it's 6 inches, 9 inches, 12 inches, and 15 by 15 inches, 18 by 18 inches, like this. So the diffuser which we can use over here is in between 6 inches and 9 inches. If you will go for 6 inches, it will be undersized. So we'll go for the higher side, so 8.5 inches. So we'll go for 9 inches. So this is how this diffuser size is coming. So 8.46 inches we are going to use, 9 inches, 9 by 9 inches supply return diffuser we are going to use over here. So let's move to another FCU to do the same exercise once again. As you can see that here we use 5 diffusers, 179 CFM each, 9 by 9 inches. So let's check this one also. CFM divided by 400 multiplied by 144 and take a square root of this one, we got 8.02 inches. As I told you, standard size is 6 inches by 6 inches, 9 inches by 9 inches. So we'll go for 9 inches by 9 inches for this one. So as you can see that we have used 9 inches by 9 inches over here. So let's move to the supply data sheet, how you can select diffuser from a supply data sheet. As you know, the different type of diffusers we can use: ceiling diffusers, 1-way, 2-way, 3-way, or perforated ceiling diffusers like this, and different decorative type ceiling diffusers we can use. As you can see that this supply air ceiling diffuser 4-way is here, and this is the size in mm. 9 inches equivalent to about 225 by 225. So we'll go over here and let me zoom this one. And as you can see that this is the velocity in meters per second, this is the flow rate in meters per second, this is the velocity in meter per second, this is the pressure drop in the pascals, and this NC is the noise criteria in decibels. So we will have to go for 225 by 225, and we know the flow rate for this one. If we want to convert this, as you know in the drawing, how much it says 199 CFM. So let's convert 199 CFM to liters per second. It will be 94 liters per second around. So if we'll go over there for 225, the 94 liters per second, it will be in between 92 and 104. So this is how you can select diffuser from supply data sheet. And noise criteria will be, if you will go for it will be less than 15 decibels. So between 92 and 104 it will come somewhere here. So You can also get the noise criteria in decibels, and you can also get the pressure drop in pascals in between 9 and 11. It will be like 10 pascals. So it will also be helpful for you to calculate the fan ESP later on. So this is how you can do the diffuser sizing, and you can select diffusers from supply. Today I am going to explain you guys the duct traverse topic, like how to perform the duct traverse to get the accurate velocity reading, and then calculate the actual volume flow rate across the duct to compare it with the design airflow rate. And this we are doing for air balancing purpose. So let's start. As you can see that we have this duct, and if we want to perform a traverse on this duct, we need to make holes to get the flow rate, and the instrument which we are going to use to perform this traverse is the velocity probe or pitted tube. When you are using the pitted tube, it will give you the velocity pressure. Then the individual velocity pressure must be calculated for each velocity pressure reading, and then averaged together to measure the velocity pressure, and then converted into velocity in feet per minute. So as you can see that this is the duct which we have, and we have inserted the pitted tube inside to get the velocity pressure. As you can see that pitted tube basically measures the total pressure and the static pressure to determine the velocity pressure. So you can see that this is the manometer, and the positive port of the manometer is connected to the total pressure port. This is our total pressure, and this one is connected to the positive pressure port of this manometer, and the negative is connected to the static pressure. And when you insert the pitted tube inside, it basically senses the total and static pressure and the manometer over here, and it measures the velocity pressure. That is the difference between total and static pressure. When you insert the pitted tube inside the duct, make sure that this tip must be pointed directly in, and it should be parallel to the airflow rate. This is the airflow rate, and this is the pitted tube. Make sure that it is parallel with the airflow rate. If you put the pitted tube accurately, then velocity pressure indications will be at its maximum. So when you are using pitted tube inside the duct, you will get the velocity pressure reading on this manometer. Then you need to convert this velocity pressure reading into the velocity, and then using Q is equal to V, a formula, you can get the actual flow rate. And so this is the table which we are going to use for duct traverse of rectangular duct. As you can see that this is the whole quantity required, and this is the interval C, interval B, and this A is representing as the duct dimension. That is 10 inches, 12 inches, 14 inches. And this table, the duct size is applicable if duct size is less than 48 inches. And for this table we need to refer to figure 1. This is the figure 1, and the interval which I have explained above, that is B and C, you can check from here in this figure. This is the dimension of the duct represented as A, as you can see over here. If we have 10 inches duct size, then A will be 10 inches. Then we need to check how much is the interval B and interval C, and how many holes required for duct traverse. 4 holes required, and B is 1.25 and C is 2.5. So the B is a distance from the inner wall of the duct to the center of the first hole, that is 1.25 for 10 inches duct, and then C is from center of first hole to the center of second hole, that is 2.5 for 10 inch duct size. And the whole quantity is 4, we already know, so we have 4 holes, 1, 2, 3, 4. So it depends on your duct dimension. If you have 30 inch duct size over there, then you need to make 5 holes with the interval B and C as B as 3 inches and C as 6 inches, and this table is applicable if duct size is less than 48 inches. If you have a duct size more than 48 inches, you still need to make 8 holes to perform the duct travels. But the interval B and C, if you need to calculate the intervals, that is hole to hole distances, and from the inner wall to the first hole, and then from inner wall to the last hole distance, you need to get these distances from this figure. So as I already explained you, we can use either velocity probe or the fitted tube to perform this duct traverse. If you perform duct traverse with the velocity probe, you can get directly the velocity, but if you perform this with the fitted tube, you will get the velocity pressure, and then you need to convert this velocity pressure into the velocity by using this formula. That is, velocity is equal to 1096.7 into square root of hv divided by d, where v is the velocity in the feet per minute and hv is the velocity pressure in inches of water from the measuring device, and the measuring device which we use in the fitted tube, that is manometer, and d is the density of the air in pounds per cubic feet. If we are using this velocity probe, we can get directly the velocity readings like over here. So let's take an example. We have 48 inches by 40 inch rectangular duct, and we need to perform a duct traverse on this duct to get the actual flow rate and compare it with the design flow rate. So if you go for 48 inch duct size by 40 inch duct size, so let's take one dimension of this duct is 48 inches and move back to our table over here. So as per ASHRAE and SMACNA standards, for 48 inches duct size, hole quantity is required is 8, and the interval B and C is required as 3 and 6 inches. So number of holes required are 8. And for the second dimension, that is 40 inches over here, number of holes required are 7, and interval B is required as 2.85 and interval C is 5.71 inches. You can refer to this figure to calculate the intervals, that is B and C, for 40 inches and 48 inches duct dimension. So since the number of holes required for 48 inch duct dimension is 8 and 40 inch duct dimension is 7, so we need to make a matrix of 8 by 7, that is 56 number of points. We need to make a matrix of 56 points. As you can see that this is the position from A to H. We have total 8 points, that is representing as 48 inch duct dimension, and it is from 1 to 7, that is representing the duct dimension of 40 inches. So this is how we have created 56 number of points, that is 8 by 7 matrix. If you have 42 inches by 30 inch duct size, then you need to make a matrix of 7 by 5. So since we have 48 inches, the example which we are considering right now is 48 inches by 40 inches. That's why we have created 56 number of points, or 8 by 7 matrix. So after creating the holes, we need to insert that fitted tube inside to get the velocity pressure reading at the manometer. Let's say this is 48 inch dimension and the other is 40 inch duct dimension, and we have 8 holes over here and 7 holes on the other side. So we need to insert the fitted tube at the first point here, that is called point A, and the other one is point 1. So if we put the pitted tube inside at point A1, we will get the velocity pressure reading at point A1, and then from A1 to next A2, then A3, then A4, then A5, then A6, and then A7. If we move to this point, this will be B point at 48 inch duct dimension. So we need to put that pitted tube inside at point B1. This is called B1. If you move inside more, it will be B2, then B3, then B4, and so on and so forth. We need to put the pitted tube one by one, and we need to get the velocity pressure readings at different points. So this is our matrix, and we need to put the reading whatever we got from pitted tube, but make sure that the reading which we got from pitted tube, it's in from the reading which we got from manometer, it will be in the velocity pressure. It will be the velocity pressure. So we need to convert this velocity pressure into the velocity by using this formula. So after using this formula, we will get the velocity in FPM. So let's say we got the velocity at point A1 is 885. This is just an example. You need to go to the site and you need to use this pitted tube to get the velocity pressure, and then you need to convert the velocity pressure into the velocity, and then you need to put that reading over here at point A1. So let's say at point B5 we got this reading over here, and then you need to write each and every reading over here, and after writing all the readings, you need to sum at the point 1 and point 2, 3, 4, 5, 6, 7. So this is the duct traverse for 48 inches by 14 inch duct. So the number of points which we have taken for the reading are total 56. That is 8 by 7, and total number of points are 656. So we need to write number of points, reading points, that is 56. And now we need to calculate the average velocity. So we need to write the average velocity over here. So first we need to sum up all of these velocities. So the velocity which we have over here is 7244, and other point is 7442.9 and 7464, then 7263 and 6889.75, and then 6594.48, then 6437. So total velocity is this much, but we need to calculate the average velocity. Since we have taken 56 points reading, so we need to divide this with 56. So 881 feet per minute is the average velocity. So this is the average velocity across 48 inches by 40 inch duct. So let's say in the drawing we have a design airflow rate is 11,700 CFM. Now we need to calculate the actual flow rate across this duct by using this duct traverse method. So by using this equation, Q is equal to VA. Here Q is the actual flow rate that we need to calculate, and V average is the velocity which we have already calculated over here, that is 881 feet per minute, and A is the area of the duct, and V average, it is in feet per minute. We already calculated above, that is 881 feet per minute, and A is the area of the duct. So as we know that it is 48 inches by 40 inch duct. I will convert this into feet. 48 inches in the feet, it will be 4 inches, and the other one will be 3.33 feet. So 4 feet by 3.33 feet. So how much area we will have? That is 3.33 multiplied by 4. You will get 13.33 13.33 square feet area. So now we know the average velocity across 48 by 40 inch duct, that is 881 feet per minute, and the area which we already calculated here, that is 13.33 square feet. So we need to put the values in this equation, the average into area, that is 881 cross 13.33 square feet. So we'll get the actual CFM, 13.33 multiplied 881, so we got 11,746 CFM. 11,746 CFM. So the actual CFM which we got across this duct, 48 inches by 40 inch duct, is 11,746 CFM, and the design flow rate which was in the drawing is 11,700 CFM. This is just an example to show you how to perform the duct traverse. So this is how you can perform a duct traverse to get the velocity pressure from the pitted tube, and then convert this velocity pressure into the velocity, and you need to get the area of this duct, and using this average velocity in this equation you can calculate the actual flow rate across that duct and then compare it with the design flow rate. So this is how you can perform the duct traverse. For more videos, keep watching my channel and don't forget to subscribe.